Hi all, welcome to Unit 3, Lesson 7. Our topic today is solving trigonometric equations with identities. So this is actually our third lesson working with identities, and I'm hoping you're all doing pretty good with this. So pause the video, try the warm-up, and then we'll solve it together. So the warm-up says solve the equation this. Again, start with the most it's an equation, so we're not proving here. So I want to move what? The cotangent x on the other side. So it'll be 4 cotangent minus equals 0. Right, we're going to factor these somehow, or let's see. What's common in them? I see cotangent x, and what are you left with? 4 cosine square x minus 1 equal to 0. And look at this. Can you factor this? Yes, you can. It is, if you think of it, it's two terms and they're both perfect squares, difference of two squares, right? So cotangent x, this would be 2 cosine x minus 1, 2 cosine x plus 1 equal to 0. Make a t-chart. I get cotangent x equal to 0, 2 cosine x equals 1. So cosine x is equal to what? 1 over 2. Right, we'll do the angles. Let's solve it first. And then here I get cosine x is equal to negative half. Right? So now let's do one thing at a time. When is cotangent x 0? Wherever our cosine is 0, right? So our cosine is 0 at what values? 90 and which is pi over 2 and 3 pi over 2. Right? So cosine, where is cosine half? Cosine is, first of all, it's positive, so you're going to be in the first and the fourth quadrant, right? So it is a half for what x values? It is pi over 3, and in the fourth quadrant, it will be 5 pi over 3, right? And when is cosine negative? Cosine is negative in these two quadrants, so what x values will that be? It would be 2 pi over 3 and 4 pi over 3. So these are your 6x values between 0 and 2 pi. Okay, so now let's get started with the lesson. It says sometimes trig equations contain different functions which cannot be separated. In order to solve these equations, you need to use one or more of the trig identities to convert the equations into one that can be solved. So this lesson is basically a combination of your identities and your equations also. So basically when you see more than one trig function in an equation, you might want to substitute with a known identity. Okay, that's what it's basically saying. So let's get started with the first equation, and I already see I have sine square x and then I have cosine x. So what can I substitute? If you are thinking that I can substitute sine square x with what? 1 minus cosine square x, right? Where is it coming from? I'm just going to quickly write that. Sine square x plus cosine square x is equal to 1, right? So if I was to solve for sine square, it would be what? 1 minus cosine square x. So that way, why did we change it? Because then my whole equation is in one function, and if I need to factor it or solve it, I will be able to do so. Right? Distribute the 2, I get what? 2 minus 2 cosine square x plus 3 cosine x minus 3. Simplify this. So I want to factor out the negative 1 also, so I'm going to rewrite it as 2 cosine square x minus 3 cosine x plus 1 equal to 0. So this is pretty simple now. Again, the structure, there are 3 terms and the leading coefficient is not 1. So you're going to do the AM method. You're going to split the middle term into your 2 factors. So this is what going to be, you need 2 numbers that multiply to 2 and add to negative 3, which is negative 2 and negative 1. So 2 cosine square x minus 2 cosine x, you're basically splitting this middle term into these 2 factors, and I'm going to write that. Minus 2 cosine x plus cosine x plus 1. Oh, it was minus cosine x, my bad. It's negative 3. minus cosine x plus 1 equal to 0. So now do the GCF. You're left with 2 cosine x. So you're left with cosine x minus 1 minus 1 cosine x minus 1. Right? So this simplifies to what? 2 cosine x minus 1 and cosine x minus 1. Make up your t-chart and set each of them equal to, what do I get cosine x equal to? I get cosine x equals 1/2. So x is what? When is it's a positive, so cosine will be, x will be what? Pi over 3 and 5 pi over 3. Because cosine is positive in the first and the fourth quadrant. This would be cosine x equals 1, so x is equal to 1/2. Oh, not just 1, my bad. I don't know why I did that. There's no 2 here. So cosine, so what is x equal to? Cosine x is 1, so when is, for what cosine values x is 1? It is 0. And be careful, 2 pi is included. So yes, 0 and 2 pi. So those example 2. So here, be very careful with the domain. The x is between, the x is greater than negative pi over 2 and less than pi over 2. So, okay. So anytime you have an equation with 2 trig functions, you want to substitute one of them so that you can have the same trig function. So if I look at my secant square x, I can substitute that with 1 plus tangent square x. Anytime you have a squared term, always think that can it be substituted with one of the Pythagorean identities. So that should be like your first go-to thing. Minus 2 tangent x minus 4 equals 0. Let's solve this. This would be what? Tangent square x minus 2 tan x minus 3 equals 0. Right? Again, identify the structure. You need two numbers that multiply to negative 3 and add to negative 2. So they are tan x minus 3 and tangent x plus 1. Right? So make up your t-chart. Set each of them equal to 0. What do I get? Tangent x equals 3. X is equal to arctan of 3. Now, how about this one? Tangent x equals negative 1 is gonna be, tangent is negative 1 in the second and fourth quadrant, right? And it is for negative, 3 pi over 4 and 7 pi over 4, right? Those are your two values, but look at the domain. It is what? Greater than negative pi over 2 and less than pi over 2, so only 7 pi over 4, or I can say negative pi over 4, right? So finish up the remaining of the problem set. Good luck.